Okay, on the last screen, I found that 6 and negative 1/2 were two zeros. And then I'm left with 2x squared plus 8. Now, this I don't need to factor. I can just set it equal to 0. Since it's missing my middle term x squared, I'm just going to move my 8 over, divide by 2. So that's 2x squared equals negative 8. Divide both sides by 2. X squared equals negative 4. And you're going to square root. And anytime that you physically draw in a square root, you have to put a plus or minus in front of your square root. A negative underneath your square root means an imaginary. And the square root of 4 is 2. And then so you've got plus or minus 2i. So depending on how I ask you this question, if I ask for zeros, you're going to list 6, negative 1/2, 2i, and minus 2i. If I ask for them as factors, you're going to list 6 as x minus 6. Now, you're going to be careful. You're not going to list this as x plus 1/2. You're going to list this as 2x plus 1. So 2x plus 1, and then, oops, this should have an I. X minus 2i, x plus 2i. So depending on whether I ask for your factors, your real zeros are, oops, these two. If I ask you for all of the zeros, you give me all of them. If I ask for factors, you give me all of those ones that I've listed here. Next, we're going to look at Descartes' rule of signs. This basically is another tool to help you eliminate some of your choices. It tells me the number of positive zeros, so when you list all your numbers, how many positive numbers you have is the number of sign changes from f of x or less than 2. And the number of negative zeros is the sign of f of negative x or by less than 2. So what that means is I'm just going to give you an example, and it'll be easier to show. And again, this is kind of like the list. It just gives you a list of possible amounts of zeros. It doesn't give you the actual zeros. So if I look on my f of x, I'm going to use that to find my positive zeros. I'm going to look for sign changes. I went from negative to positive. That's one sign change. Positive to negative. And then negative to negative is not a sign change. So that's 2 sign changes. Or whatever number I give you here, you're going to keep subtracting 2 until you get to a number that's 0 or higher. So I either have 2 positive or I have no positive. So that you've got one of those two choices. So, for example, when you're doing a problem, if you get positive 3 as one of your zeros, you know then that means that if positive 3 went into this or whatever the problem was, if you knew you had to have 2 positives, then it meant you had to find one more positive. And then my negatives, I need to find f of negative x, which means I need to substitute negative x in for my x and check for my sign changes. So that gives me positive 3x squared plus 2x squared plus x minus 1. And if I look at my sign changes, I went from positive to negative here. So that means there's only one negative real zero. So you can't have 2 negative real zeros or no negative real zeros. It means you're going to have one. Okay, 6x to the 5th plus 8x squared minus 10x minus 15. So if I want to look at my positive real zeros, I'm going to check my sign changes. I went from positive to negative, and so I have one positive real zero, because there's only one sign change. So for my negative, that gives me negative 6x to the 5th plus 8x squared plus 10x minus 15. And if I look at sign changes, I went from negative to positive, and then from 10x to 15, that is another sign change. So for my, oops, let me erase that. So my possible number of negative zeros, there's 2 sign changes or 1. Oops, sorry, or 0, not 1. Negative real zeros. Okay. So now let's take a look at complex zeros. So if you remember those from Algebra 2, they're in the form of a plus or minus bi. It's kind of hard to see the minus because of the picture. So sometimes you have non-real or imaginary zeros. That just means that your graph will reach a maximum and a minimum, but will not go through the x-axis. So remember in class we talked about your graph might look something like this, or something like this, where it basically dips down, but it doesn't quite hit the x-axis. Okay, so for this, let me see. Okay, for this, you need to remember that imaginaries come in pairs of 2. So if a plus bi is a 0, then a minus bi is also a 0 conjugate. You do not change the a. The only thing you do is you change the sign in the middle. 1 positive I, 1 negative I. Imaginaries always come in pairs of 2. So that means even if I only give you one of the imaginaries, like let's say I say, for example, 4 plus 5i, you have to assume that also 4 minus 5i will be a 0. So even if I tell you one and I don't tell you the other one, you have to assume it's there. They always come in pairs of 2. You cannot have one imaginary without the other. So for example, if I want to write the equation of a polynomial with the, oh, that's supposed to say roots, not rots. With the roots of 2, 4, and 3 minus I, for my equation, I want, if it's a minus 2, I want that as x plus 2. 4 will give me x minus 4. The 3 minus I will be an x minus 3 plus I, because you're basically doing x minus 3 minus I, and you've got to distribute the minus sign. You're also going to have x minus 3 minus I as the other possibility. So this is my equation, and if I tell you to multiply it out, you multiply it out. But for right now, unless I tell you, you can just leave it in the factored form. Okay, next example. F of x equals x to the 5th plus x to the 4th minus 13x cubed minus 23x squared minus 14x minus 24. So I want to find all the zeros of the factors. I want to use Descartes' rule of sign and the rational zero test to assist you. So first things first, I'm going to see how many zeros I have of what kind. So first I'm going to use Descartes' rule of sign. That's my first step. So I have one sign change only. So that means for my positive, there's only one positive real 0. For my negative, that's going to be f of negative x. My x to the 5th will change signs. My x to the 4th will not. My 13x squared will change signs. The x squared won't. The x will. Minus 24. So for that one, I've got one sign change, 2, 3, 4. So my possible negative zeros are going to be 4 zeros. Or remember, you keep subtracting 2. 2 or 0, negative zeros. So I'm either going to have 4 of them be negative, 2 be negative. Oops. Let's erase some of this. Oh, that's an or. Or none are negative. That's the first step. Just to give you an idea of what you have. Then step 2 is, oh, I don't like that color. Let's change this. Okay. Then next step is I want to see what my list of possible zeros is. So I'm doing all the factors of 24 divided by all the factors of 1. So really I just have 1, 2, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 8, plus or minus 12, plus or minus 24. Oops, I forgot 2. Plus or minus 4, plus or minus 6. Okay, so let me add a screen and we'll do it on the next screen. So on the next screen, we're just going to try all the possibilities in synthetic division and get it down as low as we can go. Okay, I am going to try in my synthetic division. So 1, 1, negative 13, negative 23, negative 14, negative 24. I'm going to try 4. So that's 1, 4, 5, 20, 7, 28, 5, 20, 6, 24, 0. So I found 1. If I try another one, I'm going to try, let's do a negative number and try a negative number. 1, negative 2, 3, negative 6, 1, negative 2, 3, negative 6, 0. So the negative 2 worked. Let's try, I know that if I have at least one negative 0, that means I have to have another one. So let's try a negative 3 on this. 1, negative 3, 0, 0, 1, negative 3, 0. So that gives me 4, negative 2, negative 3. And so I'm left with x squared plus 1. And when I set that equal to 0, it gives me x squared equals negative 1. So x, when I square root, will give me plus or minus I. So let me go on the next screen. So I had 4, negative 2, negative 3, I, negative I as my zeros. So again, we had 1 positive, 2 negative, and that's what it possibly said. It said I would have 1 positive, and I could either have 4, 2, or 0 negative, and I have 2 imaginary, or 2 complex. So if I write them as factors, that's x minus 4, x plus 2, x plus 3, x minus I, x plus I.